How do we detect humans?
I mean,
Are we talking to a human now or a robot? No, I think
clearly a robot. I'm an AI.
I think
The real Ismael is more handsome.
that's true, actually. Yeah.
It's funny.
Yeah, I mean, I can kick off. Ismael, excited to chat. I think we've been talking for a while. I think you guys are doing a lot of exciting work around ZK and their use in the blockchain ecosystems. And I think more recently, some of the applications in the AI space. And Logan and I got together a couple of weeks ago for a mini series on the intersection, which is small and nuanced. And we're trying to figure out what it is and what's hype versus real in it. So excited to chat.
Love it. And I appreciate you guys having me on, Sergey and Logan. You know, I've been a big fan of what you're building at Axler for a very long time, Sergey. You know, you've been one of the people who've been very supportive of us at Lagrange since quite early on. And so you told me over dinner that you guys started doing this, and I couldn't wait to hop on and be a guest. So thank you for having me.
I'll try not to throw too many curveball questions your way. Perfect. Maybe for those that are not like super deep with your background, maybe like a quick primer on Lagrange and like what we're doing, and then we can get into like the specific intersection with like crypto and AI.
Yeah. So I think that's a great way to kick it off. And so for some context, Lagrange is a ZK company. And I like to say that very broadly, because Lagrange has, throughout its history, tackled many of the largest and hairiest problems in ZK's application to crypto, all the way from compute over on-chain data verifiably for the context of DeFi and NFT apps, all the way to generating proofs for very large rollup ecosystems. And now our fastest growing product and our marquee product is something we call DeepProof, which is a ZK machine learning library that we believe has very broad applications for adding verifiability, trust, and security to inference from ML models, both in the Web3 context and then in the traditional software context as well. This is something we launched very recently. The early benchmark numbers put it at the most performant ZKML library in the space by a very wide margin. And it's an area that we have shifted very large amounts of time and resources into, and will continue to compound on our efficiency advantage.
Nice. So I guess maybe to dive deeper on that, I'm very curious to understand like what it is is this a library? Is this a, program in runtime? And I think in general, right, like ZK sort of, while it stands for zero knowledge, I think your primary uses of it are not privacy related. They're more verifiability related, right? And kind of correctness related. So maybe you can talk a little bit about that and like what it means and how you guys apply it.
Yeah. So that's a great question. So at the core, our prover is based on sumcheck and then a GKR with logup. And so it's very performant for generating proofs of arbitrary ML inferences. And so the way the library works is you take an Onyx file from some machine learning model that you'd want to generate a proof for. You put that into the library, we quantize the model, and we are able to take each of the modules within the Onyx file. We have corresponding circuits for those, and then we're able to construct a series of circuits that allow us to generate a proof of the inference for the whole model. And with that, we're able to take really an arbitrary input of a model and then be able to generate a proof through the library. And so the comp I'd like to give people to kind of conceptualize that as you think of like what a ZKVM can do for a Rust program, DeepProof and our ZKML library can do for an ML model. And so you brought up a very good point about, what is in the scope of what we do at DeepProof, right? So verifiability obviously is the thing that I talk the most about, because I think that's the most relevant in the crypto context of how you can take a world of complex off-chain compute and off-chain inference and make that verifiable on-chain to move and manipulate assets, the whole sovereign agent thesis. But we also support things that are privacy related, but it's very important kind of to be clear on where privacy fits within ZKML. So, if I'm running and generating a proof for you on my network, obviously the inputs can't be private because then I wouldn't be able to generate a proof of the inference. You could, for example, generate a proof of inference privately, but then I couldn't really verify what the inference was over. So generally the inputs have to be public in a lot of these schemes. The part that you can have private, that's actually a very powerful primitive, is the model weights, where you can have a model that has, you have a commitment to that's public, but the actual underlying architecture is private. And that's a very interesting use case where you can start, for example, being able to compare properties of models in a way that's publicly verifiable. You can have publicly verifiable proofs of fairness. You can have publicly verifiable proofs of performance without ever having to disclose the underlying model.
And maybe to kind of wrap it back briefly to like the product aspects, this whole like notion of verifiability, I think, is fairly well known within the crypto space. But now that AI in general is getting better and better each day, verifiability in terms of like, did a human generate this or AI generate this is becoming more and more important. When you say verifiability, how are you kind of thinking of it in context of both AI and crypto for the broader audience, just to make sure that they're following along?
Yeah. So this is one of my favorite questions, because verifiability is, to your point, a concept that in many ways has originated in blockchain, where the largest market for ZK is crypto. ZKML in verifiable inference is the one area that I actually see ZK probably breaking out of crypto and becoming just a massive market opportunity in the broader world. And so, to give a very concrete example of where this is useful, think about deepfakes and in content that could have some type of illicit composition. Well, you can run on your side a model that will then detect and flag content that's deepfakes, or you can take that same model, generate a proof of it, and tag the image itself, such that any other person who sees that image understands it ran through a model that was designed to detect, illicit content, images of violence, and deepfake content. And so you can start like actually developing these systems that have very succinct proofs of relevant properties to content that can be embedded into content itself. And that's actually one of the use cases that we're targeting with one of our partners that focuses on deepfake detection and building models for deepfake detection. There's a lot of things with this that are relevant outside of crypto.
I'm actually curious on your view on this, but so, a couple of weeks ago we had, Dan Bonnet on an episode, and he talked about a standard for, providing cryptographic guarantees to images that are generated from cameras, right? To make sure you can authenticate and make sure, a specific like camera or specific source took the actual image. You guys are talking, let's say, about ZK applied to computations, right? And I think one of the questions that comes in is like, if there is a content, let's say an image, whether or not it was generated, you can say by a camera or by a specific computation, but it's also very important to be able to prove not statements often as well, right?
Yes.
So as example, if I give you something that does not have a cryptographic proof, I might want to be able to tell you, hey, I actually took that image myself with my cell phone camera that did not have any fancy cryptography, but it did not come from AI model. Curious if you have like thoughts on it or how you think about it, because I think it's a very important property as well.
I totally agree. And so I've heard a lot of these kind of theses about, or pitches about like, hey, we're going to have a tested sensors and devices that are going to sign and authenticate content as real. So like my camera will have a trust execution environment with a key, and I'll sign a hash of the image. And there's obviously more complex schemes than that as well. The problem that I've always felt that those have is that they don't factor in the natural entropy of the internet. Like the amount of content that just gets distorted and changed and remixed and recomposed and screenshotted, and the screenshot gets put somewhere, then people put text over it, then they change a corner, they chop a little bit of it off. There's so much like changes that are made to images, right? You upload a picture of yourself onto Twitter and it will crop the image and thereby change the commitment to the image. And then you download that image and all of a sudden that doesn't correspond to the hash of the image that you got from your camera. And so now it's impossible to prove that image originated back from the same.
I mean, you can use ZK for that as well, as right, like
you could, but then there's just so much entropy. Like there becomes a point where trying to track the provenance of every piece of content ever produced back to the original piece becomes a very difficult problem, especially when the majority of content that exists today isn't attributable back to a source. And to me, it feels like boiling the ocean a little bit. What I think the more natural approach would be is using models that have the capacity to detect if an image is generated by a deepfake, or if an image contains some type of illicit content or some type of violent content. And I think if you look at it from just a standpoint of we're going to use models to kind of identify and prove properties of content, you can constrain the damage that this content can do in the social platform or in some consumption domain without ever having to try to map and track the entire input to that domain. And that's where I think that the space will move.
I see. Okay, no, that makes sense.
But maybe it doesn't. It's just one of the applications of ZK.
I guess like back to your point. So what you guys do, you take sort of a description of a model in Onyx file, which you said, right? And you help generate like proofs of kind of correctness around it.
Of inference, yeah.
Of inference, yeah. So I'm curious how you deal with, randomness. Right? A lot of the inference requests are randomized, or they need to be randomized. So what do you guys do to strip off, any of those things? Do you create deterministic execution, or how do you deal with it?
Yeah, it has to be deterministic or have a seed for the randomness. That's part of the model. Otherwise, we wouldn't be able to generate a proof of something that isn't deterministic. So that is one of the constraints.
And what's the overheads? Like, give us some examples of.
Yeah, overhead on generation for most models, I'd say, is probably about like X to 1,000X right now, depending on the model. It'll be smaller if you're talking about like a decision tree or something like that. But for LLMs, it'll be high. But I think one of the important areas to kind of consider in ZKML in general is that, or in ZK in general, is that the cost decay we see and the overhead that we see on proof generation is dropping by an order of magnitude plus per year. We've seen this over the last several years as we've gone from like Circon and Socrates and all of these kind of Groth and Plonk based proving backends all the way to now using kind of small field Starks and ZKVMs and kind of now hardware acceleration in the back end, both GPU and ASICs and more general purpose cryptography chips that have really brought the cost of proof generation for arbitrary programs down substantially. And we're going to see the same thing with ZKML, right? There's going to be new approaches to quantize models to make float point operations easier to prove in circuits. There's new approaches that are going to be done to kind of move, in our case, some check-based provers onto GPUs efficiently, where we can have much better performance, onto ASICs. We can have much better performance. There's new classes of cryptography focused chips coming out that will be much faster as well. And so, there's strong tailwinds behind kind of the efficiency improvements where you can see a world where this will be sub 10x within a year or 2 years.
For those in a little bit more layman terms, where does majority of that kind of like speed up or increase ultimately arrive from? Is it advancements on the software side? Is it more like tailored hardware, either with GPUs or ASICs? Where is the majority of that speed up coming today, and where do you think it's going to continue to come in the future?
Yeah. So, I think it's the good thing about ZK in general right now is that it's like such a well-financed area of crypto that there's speedups coming from like everywhere. So there's speedups that are going to be coming from actually the model architecture side. I think we're going to have new classes of models that are much faster to actually prove. And so you can develop an LLM that's very, very efficient to prove. The example I give is like if you were looking at hash functions, a Poseidon 2 is much faster to prove in circuit than a Ketchak. And so you've developed computation to be faster to prove in circuits. And then we're also going to see improvements, and we are seeing improvements on the hardware side, which is always kind of just a rising tide for ZK. And then obviously improvements on the actual proving system side as well. And optimizations and circuit writing and fewer constraints and things like that. So there's like so many places that this stuff's getting faster. I think it just creates this multi-vector or multivariate kind of optimization.
I'm curious if you spend as much time on crypto Twitter as perhaps the VC landscape.
I do.
It's interesting because really over the last like 12 months, and why Sergey and I really wanted to kind of kick this off is because the narrative at the time was really around AI agents, around either decentralized inference, kind of around potentially decentralized training. Maybe that's not as far advanced as the inference side, but really focused on kind of like those three key applications, and then ultimately verifiability of like photos or videos, as we've kind of spoken about. How have you kind of like seen the space as a founder very deep in this field, focus on the zero knowledge side of things? What is kind of your hot, spicy take on the current meta within crypto AI?
Yeah. So I actually think that there is a massive number of applications in crypto XAI that people are just beginning to kind of understand. And I would include ZK within crypto XAI, though, if we want to pull that out later, we can discuss that. But like going all the way from like the obvious ones, right? You have a bunch of DeFi agents that are going to start using AI to some capacity, to LP positions, to move funds around. And, one of the interesting things you can do with ZK there is you can have models that are publicly verifiable as to being used to move funds around, where the weights are private and the architectures are private, so you can preserve alpha on the model. Right. And that's a very interesting strategy where you can have these like publicly verifiable quant funds on chain. And I think we'll see a bunch of stuff that ends up generating a bunch of returns, gaining a lot of mindshare on Twitter that do that type of thing. And that's cool and right down the pipe. And then you talk about like, well, where are we going to see AI useful in like 6 months, 12 months, like a slightly midterm timeline in crypto. And I think you're going to see a lot of changes in user interaction dynamics on chain. So wallets, for example. You're seeing a bunch of teams, ThirdWeb, MetaMask, Coinbase Wallet, start doing POCs and start talking a little bit about having actually LLMs being used as the primary mechanism for a user to interface with the blockchain, right? Say, I want you to take my assets that are on Ethereum. I want you to take a loan against them. I want you to bridge that over onto Arbitrum or then onto Hyperliquid. And I want you to open up a long position on this asset. And you specify that in natural language. And all of the transaction semantics are going to be generated by the model. And so you say, well, that sounds like intense. It is, but it's also a lot more expressive, right? You don't have to have these complex DSLs. You can just use an LLM that's been fine-tuned to generate, sequences of transactions over popular contracts with some set of kind of constraints in place. And you can see that kind of becoming this massive market where you're starting to rearrange what it means for a user. Most people in the world have used ChatGPT, or more people in the world have used ChatGPT than have interacted on a blockchain, where now all of a sudden there's this delta of new users who actually can interact on chain without having to learn anything new, right? I think that's one of the ways we might have onboard the next billion users on chain, just by making wallets LLM based. And then you talk about like the really far reaching use cases that are like moonshot. And those I think are really cool too. And that's like your whole life runs on through AI, right? Your kid goes to an AI school and you have a self-driving car that takes you places every day. And you need to understand that the models that are being used should be provably fair. They should be trained in a way that has collective ownership so that there's not a single entity that has the capacity to architect every area of your life. It'd be pretty dystopian if it was. And then that the models are correctly being used in the correct context. Your car doesn't drive off the road and your kid doesn't end up chatting to some random person, sitting in Alabama. Like you need to make sure that like there are guardrails in place around how AI is being used, all the way from trust and safety to things like provable fairness and properties of the underlying model themselves, provable fine-tuning, what data is being used, etc.
Definitely bought into the self-driving cars and the robots. I don't know if I'm sold, though, on the AI teachers. I'm sure it's going to happen. I just need to believe a little bit more.
AI tutors, maybe.
Yes.
I'm actually maybe I'll challenge a little bit some of the stuff you said.
Let's
So
do it.
first, I think the use cases that you mentioned on the intersect, even like wallets being like driven by LLMs or like AI. I guess in my head, it's not directly almost like an intersection of the fields. It's more like an application of one on the other, right? And I think those, we'll definitely like see, like we would see all parts of software being like incorporated with AI. Do you leverage it or not? Verifiability and some of the things that you talked about earlier, in my case, in my head at least, like that is an intersect, right? It's one technology enabling the other and vice versa, right? Where I think almost like could not exist with one another. But on your last point, how do you like you live in an AI driven world, like everything is automated, and you talk about like being able to verify some properties, like this model is not going to drive your kid out of zone. How do you do that? Is the cryptography the solution? Like we don't even know how to figure out what the model is going to do based on your simple questions most of the time during the day. So how do you do these more complicated things?
Yeah. So I mean, there's like the simple one, like the model it lacks bias of some type, right? And it's rather straightforward. I'd say like some fairness properties you can do where you run a bunch of inference and generate proofs of that inference over what the output is, and you prove with another model that the output of those doesn't have a bias, right? So you have something that classifies content as being left-leaning or right-leaning, and then you ask a bunch of standard questions and see if there's an augmentation of the model left-leaning or right-leaning. You can build that today with verifiable inference with the tools you have available. And you can say like, okay, that's kind of in many cases 0 to 1 if your life is going to be somewhat heavily augmented by information coming from AI, right? Like if you're trying to make sure that the AI tutor you have isn't indoctrinating your loved one towards one side or the other, it'd be nice to have a proof of the fairness. And that's kind of right down the middle. And then the application of cryptography on top of AI, I can see the argument either way that like that might not be considered a crypto application. That just might be a cryptography application. And I think that's fair, right? Like you could say like proofs of interpretability or reasoning like Lime, and then being able to generate proofs of interpretability and reasoning, and then being able to use that in conjunction with the output of a model to say, hey, this model isn't hallucinating. This model has some sound process it has gone through to reach some decision. Maybe that's crypto, maybe that's not. I like to think of that as crypto because we're a crypto company and we build ZK tooling, but I can see the argument that it's not. The superimposition of AI on top of kind of wallet interactions, I would say that is crypto because you do need verifiability around that. Right, you need to have a certainty that the model being used to generate those transactions has been correctly run. Otherwise, I can just rug the model and rug your assets. So you start needing a lot of this verifiable inference stuff, the decentralized inference stuff, as you start incorporating any type of downstream asset ownership into the output of the model.
But that verifiability in some sense is almost like analogous to you having to trust like the wallet software, and like most people don't even like test the wallet software these days. So, it's MetaMask I install, like kind of a trusted by default. And so in this case, if it's MetaMask integrated in the model, wouldn't you like trust it by default, or you think there's that's not going to be sufficient and like the model that it uses?
I believe MetaMask is open source.
Yeah.
And so it's publicly verifiable. And then in that case, right, you are running something client side that's publicly verifiable. And that's a bit different than relying on the result of a server-side communication to generate your transactions for you, which is where I start saying you need verifiability. Because if your iPhone or your web browser is pinging a remote server to drive your transactions and sending them back to you, instead of you deriving them yourself from a reputable software client side, there's a different security model there that has to have a trust assumption of what's being sent back and forth over the wire with that remote server. And that's where the server being able to assert with a proof that the right model has been used to drive these transactions becomes very significant.
Yeah. And just kind of going back and overlaying it with, let's say, where we are as an industry, at least today, like I understand it's sort of improving dramatically, but, you're talking about overheads, that ZK will have. Hopefully those overheads will be lower. What do you think? And like overheads come with a cost, right? So if you're telling me like it's, 10x to generate a ZK, it means like the trade-in bot or somebody has to pay sort of 10x, for the transaction in some sense, right, to be executed compared to natively. What do you think is the intersect of use cases with the cost, with the product market fit today, right? Like for which ones you're certain that we know what, if there's a X overhead, people will pay for it. If there's a 10x overhead, people will not pay for it, right? And like, how do you see that for different use case types?
Yeah, and I love this question. It's in fact the exact same question that I think we have as a company continue to ask and try to answer in ZK over the last several years. Because ZK fundamentally isn't a product, right? It's a technology that allows you to add safety of computation onto another product. And so in the rollup space, we ask the same question, right? What rollup needs to be a ZK rollup and what rollup can be an optimistic rollup? Assuming it has fraud proofs, there's no difference in the safety of the funds there. There's just concerns over the safety of entrance and egress of assets and the timeline that you have to wait to enter and leave the rollup. And so in that case, there's a subset of rollups that really would need to be ZK based on the size of the capital base they have. That is leaving that rollup, and therefore the egress volume and the capital cost of the egress volume. And there's many rollups that don't need to be a ZK rollup. And the same thing applies in AI, where there are certain sets of applications that there's an imperative on safety and a certain that there's not. So if you're communicating with ChatGPT or Dolby Chat and somehow it's not the right model, or you need a proof it's the right model, probably not, right? It's a very low value interaction per inference. If you have $1 billion in an on-chain hedge fund, right, $500 million in an on-chain hedge fund, would you be willing to pay, an extra $1.50 every afternoon when it's reallocating positions? I argue you would be, because the cost of compromising that model is proportionate to the amount of capital that's secured in the protocol. So you can think about those as both two ends of the spectrum, and you can think of anything that sits in the middle as somewhere along this cost curve where there's a price sensitivity to security. And we generally think that there's some things like wallets that have, let's say in the middle, the price sensitivity to security. You probably won't use an AI wallet if it takes half your money every time you use it because it's too expensive. But you probably also won't use an AI wallet if it is going to rug you. And you probably won't put $100 million in your AI wallet, hot wallet, if it's going to rug you. So there's like stuff that sit along that curve, right? And as it gets cheaper, more of the curve becomes available. And so the stuff that's available now is a lot of things that touch assets very directly. because there's a high monetary value associated with the inference. And then over time, there's going to be stuff that are more tenuously associated with an economic value or social value or personal value that start requiring verified.
As kind of a product person myself, I very much appreciate the product focus. Sometimes, especially within crypto, I think we love these nerd battles, and don't get me wrong, I love them as well. And it's a fun rabbit hole to go down. But I think people today, whether you're kind of in crypto or like a allocator, are asking themselves the questions like, okay, where are the products and how do people actually utilize like crypto technology? Since kind of crypto's focus on zero knowledge and kind of all the investment that has gone into that, where are you kind of thinking today on the product side? Do you think zero knowledge technology is going to be leaning more towards the AI segment and focusing on verifiability and different like product use cases there? Or do you still think kind of the relevance and all the dollars that kind of went into the crypto side is going to be the primary product use case going forward, or a little bit in between?
I think it's a little bit in between. Like, I think that, there is a bunch of stuff being built in crypto that intersect with AI that fundamentally can't be built outside of crypto. And the example I'd give is like self-sovereign agents. If you can build high liveness decentralized agents in crypto that have access to be able to move funds autonomously and allocate them autonomously, and this is something that's fundamentally not possible without a decentralized consensus around the inference. And then, the centralized layer that has the capacity for wallet-own assets.
It would be great to remove the people behind the keyboards for the current iterations of AI agents and have them be fully autonomous. But I think they may get too spicy.
It would. But I think we'll get to that eventually, right? I think we'll get to that eventually because the ability to have an agent that operates autonomously increases the capacity of what that agent can do. And so you can deploy agents that handle ride routing for ride sharing apps. You can deploy agents that handle, drop shipping and creating like digital arbitrage opportunities for you. You can deploy agents that in theory would be able to, through something like ZKTLS, trade in Web 2 markets. Like there's just a bunch of stuff you can build with decentralized agents that are like really powerful and really cool. And kind of sit at this intersection with a lot of the new stuff that's been built this cycle. But, obviously a lot of it's also like a grift.
Yeah. Gotta find the middle ground and the balance there.
Yeah.
How, for kind of like the ZK novice, so to speak, or one that is wanting to kind of come up to speed, because so much funding kind of got into the broader zero knowledge space because of the focus on crypto scalability, how do you communicate to external parties Lagrange and what Lagrange is building versus all the other parties that are kind of competing in the zero knowledge space?
Yeah, I think, a few things. Firstly, we're probably the only company that has a very commercial focused strategy in ZK machine learning. We're really like a lot of the AI companies and agent companies we talk to haven't yet ever been pitched by a ZK company before or spoken to a ZK company. So, a lot of times we're explaining ZK kind of from first principles and what it can do in AI. This is very different than when we sell into like DeFi markets or when we sell into like L2 markets where there's like 19 other counterparties who also offer analogous solutions. But those spaces are very saturated. Right? The scalability space of Ethereum, it's no surprise to anyone who bought ETH, hasn't grown as fast as people had hoped for. Hence why a lot of these L2 tokens have gone down in price, and ETH has gone down in price as well, obviously relative to other factors. But yeah, for what we do, we have the fastest ZK machine learning library. It's proprietary to our company. It's licensed in a way that's proprietary to our company. We are very open to working with anyone in AI who wants to work with us, and we have moved as quickly as we can to interface and interact with some of the leading companies in AI and be able to establish those relationships in Web 2. And in Web 3, and we've also have been kind of opening up to look beyond Web3 as well and seeing where ZK can be applicable.
I'm curious also when you say, on the performance, kind of the fastest library. Tell people where to go and actually compare and do benchmarks, because I think this is a common claim from all of your competitors. I'm curious, are there standards, by the way, that the industry agreed, right? And said, like,
there's only one other company doing it. It's only one other company doing it. So I have to call them up and ask for a standard. But we have a GitHub. It's open. Like people can go and run it. Like we have a repo on this. And it's also like, I hate to say it, it's not a bold claim. Like the other one's built with Halo 2 and it's like not really, it's older, right? Like We have a very large research team, and we've put a lot of resourcing into building this with a very modern tool set and toolkit. We're one of the more mature and larger ZK companies in the space that's made a very concerted effort to have this be one of our primary go-to-market verticals. All of our code is open source, though it is proprietary licensed. It's open to be used for research and experimentation purposes. So
but you said you're pitching against 20 other companies. So are those companies like building on top of your library or this other library, or like what are they?
I'm saying in like rollups. Like if I went to go pitch a rollup, and I went to go like pitch base on becoming a ZK rollup, there would be like 20 other companies in that conversation. But for the AI stuff, there really isn't necessarily a competitive field. Mostly what we compete against is like TEs and economic guarantees, where it's less of a conversation of is ZK directionally correct, and it's more of a conversation of is ZK the correct fit right now? And those are two different things. And there's a lot of companies that would say like, hey, ZK is not the correct fit for my product at this present price point, right? Say you're building a chatbot. So the conversation there is let's understand where it would be the correct fit. And then we'll obviously understand those benchmarks against ours, and we'll work with you when that time comes.
I'm actually curious. So outside of crypto, how are the conversations when it comes to comparing trusted execution environments with ZK? And have you thought about, incorporating trusted execution environments like in your libraries or workloads? Like, do you think that would open up new use cases as of today, or you guys don't want to take that route?
Not for us. We're a ZK company. And so the focus that we have is fundamentally on verifiable computation through zero-knowledge proofs for a variety of applications, where the primary one now is AI. And so we feel comfortable doing that because we know that ZK is the directionally correct technology for this. And as a business, we've only ever wanted to and only ever will build something that we know is directionally correct over 5 years, 10 years, etc. Because if you build something that is correct on a long time scale, you have to just basically stay alive and successful and relevant long enough to be correct on that time scale. What's very hard is when you build something as an operator that isn't directionally correct, where you wouldn't necessarily say 5 years from now people will use this thing, and then you potentially can miss the opportunity. And we're very confident that we can stay alive long enough that everyone will use us, and the people using us now will keep using us.
One of the interesting thought experiments is always trying to poke some holes in your kind of logic. And honestly, for me at Frictionless, we've kind of been a champion of the high throughput blockchains. And for me, the podcast has been a super fun experiment to kind of challenge that logic and thinking and inviting people to poke holes. If in 5 years time frame, maybe zero knowledge is not as widely kind of in the AI or crypto space, have you kind of gone down that like idea maze, so to speak, and like tried to poke any flaws or logic in that to see like, hey, where's our thought process potentially wrong here?
Yeah, there's a lot of reasons, right? I mean, one of the reasons is, nobody wants verifiability as possible, right? That everyone sits there and says, I don't want verifiability. It just isn't interesting to me. We're just going to rely on a central party to do this. I generally think that's a very dystopian future, and it's one that could happen, but it's not one that we think will happen. I would also say it's very possible that over a 5-year timeline, it'll still be too expensive for a lot of use cases. Maybe we misjudged and it gets an order of magnitude faster this year, and then there's something intrinsic that stops it from getting faster for some period of time, or we start moving to model architectures that grow faster in size than ZK gets faster, which is not what we're seeing right now, right? Like we're not seeing models grow by an order of magnitude and parameters per year, and we are seeing ZK get faster and cheaper by an order of magnitude per year. So the bet is looking correct right now, but it's always possible the bet skews, right? But I think the point before, and the point that I really believe, is that if we were to look at it on like just an entirely long-term basis and say, is ZK the correct technology to add verifiability to AI, if we were not going to constrain ourselves to the life cycle of a company or the life cycle of how far we look ahead in crypto? The answer would be yes, right? That there isn't, you wouldn't say a TE is going to be the long-term answer. At some point, ZK is going to be fast and cheap enough that it replaces the TE. At some point, ZK plus MPC or ZK plus FHE is going to replace the private shared state properties you get from TEs, and we will move past that. And so we feel comfortable on that, right? It's like the same thing if you were building a business that did AI in 2003, or if you're building a business that did, you're building space travel in 2010 or commercial space travel in 2010, you're building for something that's correct directionally, but you don't know at the immediate point that it will become, the marquee market that you go on.
It took Elon quite a few blown up rockets to get to orbit.
Yeah.
No, it's very interesting. I think the space is obviously progressing rapidly. I don't know if anybody thought as many kind of venture dollars would go to increasing all the knowledge that we have, particularly around zero knowledge and pushing forward.
Over $1 billion. At some point, I did the math. I think it was over $1 billion went into various types of ZK companies.
Definitely. We're a very small piece of that.
Now we're recycling all of that into AI.
We are.
Yeah, I think it's a fascinating kind of space to watch. What things are you generally kind of most excited about, like within, I would say, the next? I mean, it's kind of hard always to do the predictions in like 6 to 12 months. I think to your point, like the 1 to like 3 years or 5 years out is a little bit easier. But what is the thing that's getting you most excited? You're generally heads down every day in the space. You're very close to the metal. You guys are obviously on the frontier building this yourselves. Is there any upcoming use cases or just like breakthroughs that you've been excited about recently?
Yeah. So there's kind of two classes of companies in AI x crypto that I see. There's a class of company that focuses on building like infrastructure for AI x crypto. And there's a lot of teams building that because infrastructure multiples are still fantastic. And I think some of those teams build tech that I think will actually be really great infrastructure that will transform it. And some of those teams build stuff that don't. And then there's a second class, which is people who are actually building novel agents, hopefully on top of the first class, but sometimes just by themselves. And that stuff is really, really cool to me. Because that stuff is you can start asking yourself, when does a consumer touch this? How does this actually impact an end user? And how does this onboard a new class of users into crypto, right? Like, how do you start having credit underwriting done in an autonomous way? How do you have insurance underwriting done, right? How do you start being able to quantify risk of positions on chain accordingly and be able to change protocol parameters against that risk, right? In a purely DeFi context. Then how are you able to then design, automated security analyses that can run continuously on blockchain contracts and be able to flag and trigger some action at the protocol level or the consensus level to stop something if there is a malicious detection on the chain. There's like a bunch of stuff you can start building that are like fundamentally net new and touch users that are agentic and that use the infrastructure that everyone has been building. And those are the stuff that I'm the most excited about. And I can go through a long list of the stuff in there that I like, but I've probably covered a lot of it already on here as well.
I'm actually curious on the opposite spectrum. I think at some point, I think you were an investor, right? Or maybe you write some checks now. What is your cautious advice for the people that are looking to invest in the space? What are the things that you think they should, you don't believe in, right? What are the categories on the either intersection that you think are not going to last
Don't forget to add a little bit of the spice.
I tweet about this publicly, guys. I tweet this stuff out, and this gets some of my highest engagement tweets. So I'm very short on L2s. I think the market's highly saturated. I think there's too many L2s.
That is a very spicy take.
Most of them don't need to exist, and the ones that do exist don't need tokens. Base is the largest L2 and does not have a token. You do not need, the next 50 L2s to launch funded by $5 to $15 million of venture dollars and a points program that launch a token and then decay to zero over the next 6 months if the unlocks happen. Like you need less of this stuff.
Is the thought there that kind of the 50 or so or wherever we stand today kind of collapses to like 1, 2, or 3, and you just kind of get a kind of consolidation of liquidity and users and applications on a single L2?
It's that L2 fundamentally becomes valuable through the distribution of people who use it. And most of these L2s that are being formed don't have a unique distribution advantage. Their only way to get distribution is through incentives. And they spend those incentives in a competition against other L2s for attention, which is generally zero sum because people rotate between them. What made Base interesting is the distribution of Coinbase Wallet, the distribution of Coinbase as an exchange. What makes Kraken interesting is the distribution Ink interesting is the distribution of Kraken. And there's other L2s that aren't announced that we know of that have unique distribution advantages, wherein they don't need a token to be able to get some nominal amount of new users to come and actually use it. And that's very interesting. But most of the venture-backed L2s that we see aren't that. It's a couple 20-something-year-old with a dream who are going to have a points program and do liquidity deals and hope that they can get attention on this thing. I'm very short on that as a concept. And we've actually seen this issue compound with the whole modular narrative too. And I love the Celestia team. I love the EigenDA team. And I think there's a lot of value to AltDA. But the problem you get with modular is just like circular money movement, wherein you have one protocol that takes $1 in user fees, that pays it to protocol 2, that pays it to protocol 3, that pays it to protocol 4, that pays it to protocol 5, that pays it to Ethereum. Then each of these ones along the way account $1 in revenue and try to go out and raise. And it just like there's no net new value creation. It's just simply a migration. And then each of these launch tokens and try to extract some bits on this.
You're sounding like high throughput, Maxi. Welcome.
I like high throughput
over.
chains a lot. I think they're a very reasonable and sensible thing to build. And I think that they're great for certain applications and poor for others.
Yep, we've kind of been championing that banner. I've learned you're kind of one of the first to go and champion things. You kind of get shot publicly.
You do.
And so it's not always fun to run out in the battlefield first, but it's something that Frictionless has kind of been saying for quite some time, and echo a lot of your sentiments. I think the funny thing to us is there's also just, I mean, a lot of it's just forks. Then you do slap on the incentive program, and then you're like, okay, what is the unique differentiation, or even from the product perspective, what can you build that is not uniquely enabled by either all the other things that exist? And so, no, definitely share a lot of those sentiments.
Awesome. What I am bullish on is L1s, RWAs, stablecoins, and AI.
So what are your most bullish L1s then?
I like Aptos. I'm sorry. I like Sui. I like Solana. I do think Ethereum will rebound. I think Ethereum does have a very strong community.
So you're in the camp of make Ethereum great one, make
no
L1
financial
great
advice.
again?
No financial advice. I'm not a trader. I'm not a financial advisor.
We will only
ignore me.
We're
Listen to me.
We're just talking about the
advice.
technology. We're not talking about tokens.
Yeah, just let me talk about AI. But I like the Miston team. I like the Solana team. And then I think there's interesting stuff with like more kind of cottage ones that have like interesting distribution. Like I think Berachain had a really very interesting go-to-market. I think Monad has a very interesting kind of architecture and a unique go-to-market. And then, the jury's out on something like Story, but we'll see. I like that it's different.
Awesome. That makes sense. Curious for the people that want to play with the stack, understand a little bit what you guys are doing. And I know you also launched some games today. I'm not sure how they'll be relevant by the time the podcast goes live, but maybe give us an overview of where people can find more, learn, play with some of the tools.
Yeah. So, the code for Deep Proof is open. Obviously it's restricted from a commercial purpose, but for academic or kind of research or for simply just experimentation, it's completely permissive to use. I'd suggest people go look at our library. It's on our GitHub. It's Deep Proof, not a very unique name, but it's a cool name. So I'd suggest people go look at that. If you're very technically inclined, there's great documentation, there's great benchmarks, etc. I'd say if you're less technically inclined, but just find this stuff cool, to your point, Sergey, we recently launched this new interactive experience that we call Turing Roulette. You basically are on this kind of text terminal, much like kind of the chat roulette, if anyone played that back in the day, and you're matched up against a random either person or LLM. And you have to guess if you're talking to a person or an LLM, and the LLM tries to trick you, and the person probably tries to trick you. And you get points if you guess correctly, and you lose points if you guess incorrectly. And if you get tricked by a person into guessing that they're a LLM, they get all your points if they guess correctly. So you have to be very careful there. But yeah, it's a lot of fun. We've seen a lot of users playing it, and hopefully it gives people this kind of more visceral understanding of why verifiability is so important in the digital age.
So do you guys generate proofs as a part of this? Okay, so at the end of the day, like if I interacted with a chatbot, like you give me a proof that this was a transcript generated by it. Oh, nice. Okay, sounds good.
Awesome. Well, really appreciate the time. This was a lot of fun. I like the banter. I like the spicy takes.
It was fun.
Look forward to seeing what you guys do at Lagrange, and excited just to continue to watch kind of the zero knowledge space. As you've kind of highlighted throughout this, it's progressing extremely quickly, both on the software side and hardware side. And there's hopefully a lot of novel net new use cases. I mean, I think AI is a direct beneficiary and kind of a very pinpointed product use case that we can all point to and say, in the future, this will most likely seem obvious as, hey, we need to discern real from fake, and appreciate what you guys have really put forth there on making that technology a reality.
Thank you so much for having me, and I appreciate you guys saying that. Looking forward to building some great stuff, and hopefully can find ways to collaborate with you guys again.
Awesome. Thank you.
Thanks for having me.
Wonderful.